Okay, let's do number 3. Word problems is why we're here, so that we can get used to how to think about solving them, working systematically towards a solution. And we saw, I think, by now, looking at the homework, if you've looked at the homework already, setting up the equations is not always the simplest thing. It's not always the simplest thing. So it does take practice, but it's a useful skill in my opinion. Okay, let's read number 3. A doctor purchased a new car in 2001 for $32,000. In 2004, he sold it to a friend for $26,000. Draw a straight line showing the relationship between the selling price of the car and the year in which it was sold, and interpret it. So they don't really define the variables. Let's go back to x and y, because I get used to x and y and their roles in this equation. Let's say y represents the selling price, and I'm going to say x represents the number of years after 2001. Not the year 2001, I count from 2001 on. Sort of the age of the car, if you want. So x represents the age of the car. Now what do they give me? They give me some x and y values. So I just write it down, get it out of the paragraph, so I don't forget it. In 2001, the car was purchased for $32,000. So at year 0, $32,000 was the value of y. In 2004, it sold for $26,000. So what is the value of x that goes with $26,000? Again, 3, you're holding up. 2 or 3? 3? 3. 3 years have passed. So the car is 3 years old, then the selling price decreased a little bit. So my goal is the same here, get the equation, and in order to get the equation I need the slope and the y-intercept, or the value of b, to finalize the equation. But the slope is by far the more difficult one, so let's do that first. I remind myself it's change in y over change in x. So I pick a first and a second point, doesn't matter which one you pick, as long as you stick with that. Change in y goes from 26,000 minus 32,000 over change in x is 3 minus 0. So what do I get? It's negative 6,000 over 3, or what do I get? Negative 2,000? How do I interpret this? Well, for me personally, if I have a slope value that's an integer, I make it a fraction. So I just put it over 1. I want to see 2 parts. 2 parts. How do I interpret this? The change of 1 year decreases the selling price by 2,000. So if the number of years increases by 1 year further into the age of the car, then the selling price decreases by $2,000. So it's very important that you can interpret the slope, referring back to the original question. Remember what the variables mean. Any questions on my interpretation? Again, there's more than one way to say it. You could say if the value decreased by 2,000, then 1 year has passed. Different ways of saying it. For some reason, I like to start with the bottom, and that affects, because this is the independent variable, that affects the change in the other variable. But more than one way to say this. Interpret the slope and the intercept. Okay, let's do the intercept. Why? But I think it's better to just get the equation first before I worry about the intercept. So I have this guy, negative 2,000. Is the y-intercept something I need to calculate, or is it already available? It's already available because they give me the y value when x is equal to 0. So there's very little to do. So my equation is negative 2,000x plus 32,000. That's my equation. Now using that equation, how do I find the x-intercept? I imagine a sketch like this. X-intercept when y is equal to 0. So I set y equal to 0 and solve for x. So I 0 equals negative 2,000x plus 32,000. So 2,000x is equal to 32,000. So x is equal to 16,000. No, just 16. Not 16,000 years. No car lives that long. 60. So that means, what does the x-intercept of 16 mean to me and the doctor that's buying this car? What is it? Silence? No. Doesn't mean
16 years, you got no car left.
Well, that's not true. It can still live.
It's the value of the car.
Value is just nothing. Depending on the type of car, it might still be around. After 16 years, the car has a 0 selling price. You're not going to get anything for it. It still might still have value to you, but you can't sell it for anything. Now, in reality, it doesn't actually work according to a linear equation, but it's just a simple function to get us started. All right. So I just quickly want to emphasize the two types of straight lines that I'm interested in. Again, we're looking at this because it serves our purpose of answering more practical problems. We're not looking at it for the sake of looking at it. So because of that, I'm not running through every little thing, every little type of equation that you can see. We're not doing pre-calculus. It's a stepping stone to learn how to think about solving problems. But I do want to just do number 4 and 5, just to sketch a straight line for the sake of it, just to make sure. So we'll do 4 and 5 reasonably quickly, just to make sure I know how the slope plays a role in my line, in the sketch of my line. So I have y equals negative 2/3 x plus 4. So when I look at the slope here, I see negative 2/3. It's just for me personally, that's the easiest way for me to interpret it. And I see this y-intercept is right there. So let's sketch the curve over here. straight line, x and y. I know the y-intercept is right there, so it's going through that point. Now again, there's more than one way to do these things. Technically, you only need 2 points, connect them, and you have your straight line. But I want to practice interpreting the slope. What does the slope mean? It means a change of 3, positive change, an increase of 3 in the x direction, goes with a decrease of 2 in the y direction. Change in y, change in x. If I increase x by 3, it goes with a decrease of y by 2. Another way to say it, if I go down vertically by 2 units, I have to go 3 units to the right. So that point will also be on my straight line. If I go down 4 units, how far do I need to go to the right? 6. And that gives me my x-intercept. By just interpreting the slope, starting at some point, I have the x-intercept come out automatically. So the key thing here is that I want to understand what the slope is telling me. And if I understand that, sketching the straight line is very easy. Now again, I understand there's more than one way to do this. You might have your preferred method, but if you don't, try and focus on the slope. Now note that if I have a negative slope, a negative value for n, then it's necessarily going to slant this way, top left to bottom right. Because a positive change in the x direction is going to go with a negative change in the y direction. So if I go to the right, I have to go down, giving me this type of line. If I look at number 5, well, they're trying to trick me here by giving it to me in a different form. Let's just solve for x. 3y is equal to 2x plus 6. So y is equal to 2/3 x plus 2. That's the one I want to see. I'm not interested in any other form. That's the one that is the most useful for me. And anything else I can rewrite to that form. I don't need anything else. So the slope here is now 2/3, positive. But I have the y-intercept right there, so let's go with 2 over there. I know it's going to go through this point, that's the y-intercept. So the reason I like this form is because for a question like this where they give me the equation, the y-intercept's right there. One of the 2 intercepts is given. Makes my life easier. Now how do I interpret the slope? My way of saying it is, if I take 3 steps to the right, an increase of 3 steps, I go 2 steps up. Can I use this argument to find the x-intercept? So if I step to the right, then I step up. 3 to the right, 2 up. So 2 steps down means, what do I do horizontally? Left by 3. 2 steps down, 3 to the left. And I have my straight line right there. X-intercept just popped out without even trying. Just by interpreting the slope. Now, it's not always going to be that effective. So I can always find the x-intercept the old-fashioned way by just plugging in y equal to 0. See if I get the same thing. So I get 2/3 x is equal to -2. X is equal to -2 divided by 2/3, which is -2 multiplied by 3/2, which is -3. So I do get it back. You always have this way to fall back on, but I do want to practice interpreting the slope, because when I get to a word problem, it means a little more there that I should be able to interpret it. Any questions on how I use the slope to sketch these straight lines? Again, we're minimizing how many or how much we're just taking an arbitrary equation and sketching it. It's a stepping stone to answering practical problems and interpreting the information there. All right, we're almost done. Almost done. Then you can go enjoy the weekend. If you've taken my advice and did the homework as we did the lectures, your weekend's free. Number 6. The average daily cost, C, for a room at a city hospital has risen by $59.82 per year for the years 1990 to 2000. But the average cost in 1996 was $1128.50. What is an equation which describes the average cost during this decade as a function of the number of years T since 1990? That's a lot of words. So let's just think about this. They give me the variables, so I can't use an x and a y, unfortunately. C is the cost. That behaves, is that the x or the y in terms of how it behaves? Is it the dependent variable or the independent variable?
It's y.
He says it's the y. Anyone agree with it? Why is it the y? Why the y? Because I want C as a function of number of years. C as a function of something else. So C is the output. T is the input. Number of years. Oops. So this behaves as my x and my y. Now what do they give me? They give me that in 1996 the cost was something. So I have a T and a C value pair. The cost is 1128.5. What is the value of T that goes with that? I have to be aware. I want you to be happy with what T represents. What does T mean? He says 6 because I'm measuring T from 1990. So the value of T that goes with this is 6. And they also give me this 59.82. What is that? Well, let's read the question again. The cost has risen by 59.82 per year. So this means if the number of years increases by 1, then the cost increases by 59.82. What are they giving me? What is this? What is that 59.82? Okay, I know it's simple. In my general equation, I'm trying to find the equation, right? That's what they give me.
It's 0.
Well, one step at a time. Cost equals slope times t plus the y-intercept. So I need to find this guy, and I need to find this guy. Are they giving any one of those to me? I agree, it's one of these. Are they giving me this one? It's not this. Because it's not year 0. This 59.82 isn't the cost at 1990. That's not the cost. That's how much the cost increases every year. So a change in T goes with a change in C. What is that? What is that? It's a slope. So I have to be happy with what the slope means so that I can identify when they give it to me. That, oh, that's the slope. Change in X goes with the change in Y. Because this can be over 1, so an increase of 1 year results in an increase of this much in the cost. Make sure that you're happy with identifying when the slope is given. So let's update and see what I still need to do to find the missing B. Now I've used this. Good. Use that. I want to use this information that they haven't given me yet. So I use the fact that C is equal to 1128.5 if T is equal to 6. Plug it into my equation. So 1128.5 equals 59.82 times 6 plus B. That's a 6, that's a B. So 1128.5, what is 59.82 times 6? We're almost done.
358 and 92.
So let's say again?
358.92.
And the value of B is what? What is the value of B?
769.58.
What was that, sorry? The last one?
And 58.
58. So my equation is C equals 59.82 T plus 768.58. There you go. Any questions on how to find this? Make sure that you can do the slope. You can identify when the slope is given. All right. It's not right? I'm just writing down what you gave me.
69.
69?
Yeah.
Okay, that's easy to fix. Is that right? Okay.